Most organizations treat Azure administration as a simple stack of technical certifications where you just keep adding more knowledge, more roles, and more responsibility. They are wrong. This perspective is a fundamental misunderstanding of what actually happens as you move from a junior administrator to an enterprise architect. The truth is structural, and it has nothing to do with learning more services or passing more exams. You have to face a single uncomfortable reality. Azure administration is the management of entropy. That entropy always wins unless you architect systems that make non-compliant states impossible to reach. This episode maps your journey through 7 distinct levels of understanding, and each level is marked by a moment of disillusionment. These are the moments when what you thought was architecture reveals itself as nothing more than high-stakes improvisation. Every step forward also marks a shift in how you view your own job. At level 1, you believe you are an administrator, but you are not. In reality, you are a human API call with inconsistent latency and catastrophic failure modes. By the time you reach level 7, you are no longer an administrator at all. You have become the curator of a distributed decision engine. That distinction matters because it determines whether your organization survives the next incident or becomes a cautionary tale. The architecture of this episode follows the same structure as Azure itself, moving from the surface level down through the layers where control actually lives. We will start with the comfortable illusions of the portal, then move through automation, infrastructure as code, and policy. From there, we look at identity and landing zones before finally reaching the edge where artificial intelligence operates autonomously. At that level, the system makes decisions and takes actions without waiting for human approval. By the end, you will understand something most Azure administrators never grasp. The job is not to manage resources. Your job is to design systems where the wrong thing is architecturally impossible. When you reach that point, administration becomes orchestration, orchestration becomes governance, and governance eventually becomes invisibility. The best administrators are the ones whose work is so well designed that no one even notices they exist. This is not a tutorial or a how-to guide. This is an argument for why your current approach to Azure is a design omission, and we are going to look at exactly what that costs you. The comfortable lie. You have been promoted 3 times, you manage the budgets, and you own the tenant, yet you are still clicking buttons. It might not happen every day, and you certainly don't do it deliberately, but you always end up back there when something breaks. When a policy blocks a deployment or an agent accesses the wrong data, you find yourself in the portal creating exceptions and adjusting settings. You are manually moving things around, clicking and hoping because you never actually designed the system. You inherited it, you maintained it, and you patched it, but you never truly governed it. This is the comfortable lie that tells you that if you have the right certifications and understand the services, you can manage Azure. You cannot. Azure is not manageable. It is only governable. That distinction matters because governance requires architecture rather than just knowledge. The real problem is that you never defined what should be true about your infrastructure. You defined what you wanted to deploy, but you never defined what was forbidden. You never made the wrong thing impossible. You just made it expensive, slow, and dependent on exceptions. By the end of this conversation, you will see your role entirely differently. You won't just learn new services or features, but you will finally understand that you haven't been administering Azure. You have been managing entropy, and entropy is the enemy of architecture. This is the first uncomfortable truth of the 7 levels, and it only gets worse from here. The portal clicker illusion. Most Azure careers begin with a mouse and a search box. You create a resource group, search for a storage account, click through a few fields, and hit deploy. When the notification pops up saying deployment succeeded, you feel a sense of accomplishment. You believe you understand the system because you saw it happen. You do not. The Azure portal is not a window into the architecture of the cloud. It is a facade specifically designed to make that architecture invisible. Every field you fill and every checkbox you toggle represents an abstraction stacked on top of another abstraction. The portal shows you only the thin slice of data needed to complete a single transaction while hiding the machinery underneath. What it hides is exactly where your future production outages and security holes live. When you click Create in the portal, you aren't actually building anything. You are sending a request to an API, which calls the Azure Resource Manager, which then evaluates policies and checks RBAC permissions against hundreds of organizational rules you never see. If the request passes this gauntlet, a resource appears. If it fails, the portal hands you a generic error like authorization failed or invalid parameter. It refuses to show you the actual system state or the decision logic that led to that failure. Every manual click is a decision point that bypasses versioning, logging, and intent. The system makes decisions on your behalf, but those decisions remain invisible to you. Because they are hidden, you cannot replicate them, you cannot audit them, and you certainly cannot explain them during a high-stakes compliance review. You are left to click again and simply hope for the same result. Believing that clicking a button equates to understanding a system is the first level of the architectural illusion. This is the uncomfortable truth. You are not an architect. In this model, you are a human API call with high latency and inconsistent behavior. You think you are making architectural choices, but you are actually just submitting requests to a system designed to process them in one specific way. The system does the heavy lifting while you act as a slow, forgetful input device. The real cost of portal administration isn't the time you waste, it is the entropy you create. Each manual click generates a resource that exists outside of version control and organizational intent. It exists as a fact on the ground that you have to reverse engineer later just to understand why it was built that way. When you scale this to 10 resources, you have 10 invisible decision points. When a team does this for a year, you end up with a sprawling environment that no one can explain or predict. The architectural law is simple. If it is not declarative, it is not managed. Declarative management means you define what should be true, and the system enforces that state. Most organizations, however, rely on imperative administration, the click and hope method. It works until it doesn't, and when the system breaks, the investigation takes weeks because the original decisions were never recorded. Eventually, you realize clicking is inefficient, so you move to PowerShell. The scripting apprentice's trap. You realize clicking is a waste of time, so you start writing scripts. You handcraft 100 lines of logic to deploy network security groups and assign RBAC roles. When the script runs successfully, you feel like an architect because you finally automated your workflow. This is where the trap closes. Scripts feel like progress because they are faster than the portal, but speed is not the same as stability. You can now deploy in minutes what used to take hours, and you can even check that code into Git. Administrators often believe they have solved the problem of manual work at this stage, but in reality, they have only scaled the chaos. Scripts are imperative, meaning they describe how to do something rather than what the end state should be. When you write a PowerShell script to create a storage account, you are issuing a sequence of commands. You are not saying a storage account must exist with this configuration. There is a massive architectural gulf between those two ideas. In the real world, Azure never stops changing, and a script that worked perfectly 6 months ago will eventually fail because an API response format changed or a module updated. The danger isn't just that the script is brittle, it's that you won't know when it fails silently. You aren't checking for the actual existence of a correctly configured resource. You are merely checking the exit code of a command. If the command reports success but the configuration is wrong, you have successfully automated your own misunderstandings at scale. This creates massive technical debt because scripts are rarely idempotent. If you run a procedural script twice, you might end up with duplicate resources or a wall of red error text because a resource already exists. To fix this, you start writing complex error handling and retry logic. Your 100-line script balloons into 400 lines of maintenance-heavy code. You are no longer managing infrastructure, you are babysitting a fragile code base. Imperative automation is just a faster way to create architectural erosion. Consider a common scenario where a dev team needs VMs with public IPs for a quick test. You write a script that handles the deployment and the team is happy, but 6 months later, you have 47 exposed VMs scattered across the environment. Some are retired, some are forgotten, and all of them are security risks. When an auditor asks why these public IPs exist, the script offers no answers. It doesn't explain the why or enforce any organizational policy. It just executes API calls without any awareness of intent. There are no guardrails to prevent the next person from running the same script and making the same mistake. Your security model relies entirely on your personal discipline and memory, both of which will eventually fail. Once you realize how fragile these scripts are, you finally look toward infrastructure as code. The IRC revelation and its trap. You eventually discover infrastructure as code. Bicep, Terraform, or ARM templates enter your workflow, and suddenly the entire landscape changes. You stop writing imperative commands and start writing declarative definitions. Instead of telling the cloud what to do, you describe what should exist, and the system simply makes it so. This feels like real architecture, and in that moment you believe you have finally grasped a fundamental truth about cloud infrastructure. You have not. You have merely moved one layer up the stack. Infrastructure as code represents the first real step toward deterministic infrastructure, which is a valid improvement. When you author a Bicep template or a Terraform module, you are defining a desired state and asserting that this specific configuration must exist once the template is applied. Because these templates are idempotent, you can execute them 100 times while consistently achieving the same result. The system ignores matching configurations, creates what is missing, and corrects what is drifted, making this approach categorically superior to manual scripting. But here's the uncomfortable truth. Most infrastructure as code implementations are just legacy scripts wearing a different language. The syntax has evolved and the tools have changed, but the underlying logic remains identical to the old ways. You still decide every detail that enters the template, and those decisions usually stem from the same flawed assumptions that caused your original problems. You might build a sophisticated bicep template that deploys a storage account with perfect naming, replication settings, and access tiers. You version it in Git and run it through a professional CI/CD pipeline, feeling organized and repeatable, yet it remains nothing more than automation without intent. The architectural reality is that infrastructure as code is a necessary tool, but it is never a sufficient solution. Without policy, governance, or a landing zone, your beautiful bicep template is just a high-speed vehicle for deploying non-compliant infrastructure. This scenario plays out constantly, where a developer creates a template that uses parameters, provides outputs, and follows every naming convention perfectly. However, if no policy exists to prevent public access or mandate encryption, that template remains a liability that anyone in the organization can deploy to any subscription. Nothing stops a user from deploying that storage account and then manually opening it to the public internet, leaving you to wonder why the auditors are suddenly sending angry emails. The template defines the mechanics of creation, but it fails to define what is actually permitted to exist. While the template serves as documentation of your intent without enforcement is nothing more than hope. This is the exact point where most organizations stall out. They invest heavily in infrastructure as code by building vast libraries of patterns and educating their teams, only to realize these templates prevent nothing. They simply make it faster to deploy resources, many of which violate internal standards or should never have been created in the first place. The real divide between meaningful IRC and basic automation comes down to one principle. The template is not the truth. The policy is the truth. Your bicep template describes how a resource looks, but organizational policy dictates whether that resource has a right to exist at all. Policy is the critical layer that separates true architecture from mere automation because it is the only mechanism that makes the wrong thing impossible. If a template attempts to enable public access on a storage account while a policy forbids it, the policy wins every time. A template can never override the fundamental intent of the organization. Most organizations possess neither the template nor the policy, while some have the template but ignore the governance. Almost no one realizes that the policy is the only part that actually matters for long-term stability. You can keep writing better templates, but they will continue to deploy non-compliant infrastructure as the gap between your perceived control and actual reality continues to widen. This realization proves that infrastructure as code is not the final answer. It is a tool, and tools used without an architectural framework are just faster ways to fail. The governance awakening. Once you realize your templates require guardrails, you finally discover Azure policy. This marks a fundamental shift in your approach, not because you are adopting a new service, but because you are confronting a new architectural principle. The distinction between what you allow and what you permit defines the boundary between architecture and chaos. The common comfortable assumption is that policy is inherently restrictive and exists only to slow down innovation with bureaucracy. People claim it makes developers unhappy by forcing exception requests and creating friction, so they argue for minimizing constraints to let teams move fast. They treat policy as a necessary evil that should be kept to a minimum to avoid breaking the workflow. That assumption is exactly what kills organizations. Policy is not restrictive, it is clarifying. A deny policy is not a hurdle, but rather the active enforcement of architectural inevitability. When you implement a policy that denies public IPs on network interfaces, you aren't slowing down innovation, you are preventing a specific category of failure from ever occurring. You are stating that in this environment, infrastructure exposed directly to the internet at the network layer is architecturally forbidden. It doesn't require an approval or a ticket because the state itself is impossible to achieve. You must understand this distinction clearly. If you create a network interface without a deny policy, the system technically allows you to attach a public IP. Even if it is a massive security vulnerability, someone will eventually do it, whether by accident or through a lack of understanding. That exposed infrastructure will be found by attackers, the environment will be breached, and the resulting failure will cascade through your entire system. When a deny policy is active, the control plane rejects the request to create that public IP immediately. The resource never exists, the state remains impossible, and no amount of accidental or deliberate effort can force it into being. Because the request fails at the source, the category of failure is effectively deleted from your environment. Consider the cost analysis that most organizations fail to perform correctly. A single misconfigured public IP can lead to a breach costing $4.5 million and requiring months of grueling incident response. You end up dealing with lawyers, regulators, and a damaged reputation while the board asks questions you cannot answer. That same policy, if enforced from day one, costs absolutely nothing to maintain. It requires no management overhead or complex approval workflows because the forbidden state simply cannot exist. The deeper insight here is purely architectural. Policy is the primary tool that transforms you from a resource manager into an architect of the control plane. The control plane is the space where every decision is made. and every template deployment is just a request sent to that decision engine. The control plane evaluates your policies and checks your RBAC before deciding whether to permit the request. Most administrators never actually touch the control plane, choosing instead to deploy templates and pray the results stay compliant. They spend their careers reacting to decisions the system already made by monitoring, auditing, and attempting to remediate problems after they occur. Architects, however, design the control plane itself. They define the policies that the system evaluates before any resource is ever born. By making these decisions in code, they allow the system to enforce those rules autonomously and at scale without needing human intervention. Deny policies function at the control plane to stop non-compliant states before they take root. This is the line between governance that works and governance that fails. Effective governance prevents bad states from existing, while failed governance tries to stop people from creating them, which leads to a constant battle that the system eventually loses. When a deny policy forbids public IPs, every single non-compliant request fails at the exact moment of creation. The policy wins, the organization remains secure, and the insecure state stays impossible. This isn't bureaucracy, it is architecture. This is the moment you stop being an administrator and finally start being an architect. The landing zone ecosystem. Eventually, you realize that policy is not enough to solve the problem on its own. While policy prevents specific actions from occurring, it still operates within an organizational structure, and the uncomfortable truth is that most organizations have no structure at all. You start with a tenant containing various subscriptions that people treat like simple storage containers. You put resources in them and assume they are roughly equivalent, labeling some as production and others as dev or test, but they remain fundamentally just subscriptions. This is the exact point where most architectural designs fail. The comfortable assumption is that a landing zone is just a subscription with a few policies slapped on top of it. You create the subscription, attach some Azure policy initiatives, add a few RBAC assignments, and tell yourself that you have successfully built a safe harbor for infrastructure. You believe the environment is secure because you followed a checklist. You are wrong. A landing zone is not a subscription, nor is it a single resource you can deploy and forget. In reality, it is a complex ecosystem where management groups, subscriptions, policies, and RBAC must function as a unified control plane. It requires the integration of networking topology, identity, and automation to create a deterministic environment where security is not an accident. When you treat a subscription as a mere container, you are committing a fundamental architectural error by assuming these units are interchangeable. You are suggesting that the only real difference between environments is the workload running inside them, which is how an administrator thinks. Architects see subscriptions as blast radius controls. Creating a subscription is actually about building a boundary that limits the fallout from human error or malicious activity. Consider a developer working in a test subscription who accidentally runs a buggy script that triggers a mass deletion. In a flat structure, that script might reach out and wipe a production database, resulting in a total company catastrophe. But with proper boundaries, that disaster stays contained within the test subscription while the production databases and their backups remain completely untouched. The developer has the authority to manage resources in their sandbox, but the subscription boundary ensures they lack the power to touch anything critical. This separation of authority is enforced by the architecture itself rather than a pinky promise or a manual process. Without this segmentation, you have no real boundary to protect your core assets. A single mistake in a script could theoretically reach every piece of critical infrastructure and delete your entire digital footprint in seconds. This is why subscriptions matter from an architectural perspective. They are not containers for your stuff. They are the walls you build to limit the radius of inevitable failures. Landing zones enforce these boundaries using 3 specific mechanisms, starting with hierarchical policy. Management group level policies ensure that every subscription inherits specific guardrails automatically, so production environments always get strict security, while dev environments remain flexible. These policies cascade down the hierarchy, ensuring that intent is enforced at scale without manual intervention for every new resource. The second mechanism is RBAC, which defines exactly who can perform specific actions within those subscription boundaries. A developer might have broad permissions to create and delete resources in a dev environment, but that same identity is restricted to read-only access in production. The subscription boundary acts as the hardline that prevents their elevated dev permissions from bleeding into sensitive areas. Finally, you have networking topology, where each subscription maintains its own isolated networks. Production workloads cannot simply reach across into another subscription over a private connection without going through a central hub. They must be explicitly authorized to cross that boundary, and every single crossing provides a new point where security policy can be enforced. Designing landing zones this way is an exercise in resilience and containment. You are building a system where the failure of one component cannot cascade through the rest of the environment. The real shift happens when you stop seeing landing zones as secure sandboxes and start seeing them as your organizational structure written in code. You are encoding your business boundaries into the Azure hierarchy, defining exactly where dev ends and production begins. You are deciding where policy changes and exactly how large the blast radius will be when something eventually goes wrong. Azure verified modules have become the new standard for this work because they are composable and aligned with how systems actually behave. The old enterprise scale models were often too monolithic, forcing you to fork massive templates just to make a small change. AVM allows you to build the specific landing zone you need by combining smaller, verified modules into a cohesive whole. Once you accept that these boundaries are necessary, you realize they require identity to function. This is the moment you discover Entra ID is your true control plane. The network perimeter illusion. You now understand that landing zones require identity to work, which leads you to Entra ID. But before you can master that control plane, you have to kill the most dangerous and comfortable illusion in the industry. It is the belief that the network is your primary line of defense. Most Azure administrators still think like network engineers because that is how they protected organizations for 30 years. They built perimeters with firewalls and DMZs, creating strict rules about which traffic could cross a physical boundary. That model works perfectly in a traditional data center where the walls are made of concrete and the cables are visible. The comfortable assumption is that your VNets and firewalls are what actually protect your resources. Following this logic, you build a virtual network, configure your security groups, and write complex firewall rules to lock everything down. You restrict traffic to corporate IP ranges and feel a sense of total control because you have built a digital fortress. This is the illusion that leads to catastrophic breaches. The architectural truth is that the traditional network is dead and the perimeter is no longer a physical location. In a cloud-native world, the perimeter is a token. Think about how access actually works in Azure today. A user could be sitting in a coffee shop in Tokyo or a hotel in Moscow when they type a URL into their browser. When that application requests data from Azure, the request goes directly to the Azure Resource Manager. The system does not ask where the user is sitting. It asks if the request carries a valid token from a trusted provider. The network has almost nothing to do with this decision. If the token is valid and the identity is authorized, Azure grants access regardless of the user's physical location or the security of their Wi-Fi. They could be on a compromised device using stolen credentials, but if the token checks out, the gate opens. The IP address and the network path are secondary details that the control plane largely ignores during the authorization phase. This scenario plays out constantly in real-world environments. You might spend weeks perfecting a network security group with deep defense and outbound traffic restrictions. You have monitoring, logging, and every bell and whistle a network engineer could ever want. Then an attacker steals a single set of user credentials. That attacker could be thousands of miles away, operating from a device you have never seen on a network you don't control. They authenticate to Entra ID, receive a valid token, and use it to bypass your entire network stack. They can open a PowerShell session to find your databases and export your data while your expensive firewall watches silently. The NSG never sees the attack because it is looking for network patterns, not API calls or identity claims. Since the attacker is using a legitimate token through a public endpoint, the network layer sees it as authorized traffic. Your security groups become irrelevant the moment the identity is compromised at the control plane. This is not a failure of your firewall configuration, but a failure to realize that the network is now just a transport layer. The real perimeter has moved up the stack to the identity layer. Every single access decision in the Azure ecosystem is made by Entra ID, which checks claims and device compliance rather than just IP addresses. It looks at whether a sign-in is suspicious or if a device meets your security standards before it ever cares about the network path. These checks are the heart of the system, and none of them are enforced by a router or a switch. The architectural truth is that a zero trust requires explicit verification of every single request every time it occurs. That verification happens through Entra ID conditional access, making the network a useful layer of defense in depth but not the seat of power. When you finally accept this, your entire strategy changes. You stop obsessing over firewalls and start focusing on the life cycle of a token. You stop worrying about network topology and start thinking about who can be verified and under what conditions. Identity is no longer the last thing you configure. It is the first and most important control plane you own. You realize identity is the only perimeter that matters, and you begin to see Entra ID for what it truly is. The identity perimeter. Entra ID as control plane. Most organizations operate under a comfortable but dangerous assumption. They treat Entra ID as a simple utility for user authentication. In their minds, it is just an identity provider where you submit credentials, receive a token, and go about your day. They view it as a basic piece of infrastructure sitting at the edge of the network to decide who gets through the door. That perspective is a fundamental misunderstanding of the system's architecture. Entra ID is not an identity provider, it is a distributed decision engine. Every single access request, whether it comes from a human, an application, a service principal, or an AI agent, must flow through this engine. At every micro moment of that flow, Entra ID is actively making a choice to grant access, deny it, or demand more proof. It might require device compliance, block a sign-in it deems risky, or trigger a step-up authentication challenge. These decisions do not just happen once at the start of the day. They happen every single time a request is made. The architectural truth is that Entra ID functions as your control plane. It does not sit at the perimeter of your systems because it is the actual center of your systems. Because every request is evaluated and logged in real time, every single decision the system makes becomes a permanent auditable record. To see what this looks like in practice, consider a conditional access policy that requires multi-factor authentication if a user signs in from a new location. This logic is evaluated globally and continuously for every sign-in attempt across the entire tenant. When a user in New York signs in from their usual office, the engine confirms the location is known and allows the session to proceed. However, if that same user appears to sign in from Tokyo only an hour later, the engine flags the new location and immediately triggers an MFA challenge. The user must then provide that second factor to prove their identity before the system grants them any level of access. This is not a static gate, but a real-time engine designed to handle millions of sign-ins while maintaining perfect logical consistency. But here is the uncomfortable part. Every exception you add to a policy acts as an entropy generator. When you build a policy requiring MFA for the entire company but then create an exclusion for executives, you have effectively engineered a backdoor into your environment. You are telling the system that a specific category of high-value users is allowed to bypass your primary security controls. While the policy still applies to everyone else, that single hole is exactly what an attacker will look for. This scenario plays out constantly because an executive finds MFA inconvenient or believes their status should exempt them from standard procedures. You grant one exception, then the CFO asks for one, and eventually the entire board is exempt from the very controls designed to protect them. If just one of those individuals has a compromised password, an attacker can walk right into your tenant because MFA was never enforced for that specific account. The architectural reality is that every exception is just a vulnerability waiting for someone to find it. Organizations that actually understand this architecture do not deal in exceptions. They focus on uniform enforcement. When a policy proves to be a friction point, the answer is never to create a special bypass for important people. The answer is to refine the policy for everyone so that the security model remains deterministic rather than probabilistic. This principle becomes an unavoidable reality on October 1st, 2026, which is when Microsoft will begin enforcing MFA for all Azure portal access. This mandate includes global administrators and offers no room for exceptions or administrative overrides. After that date, anyone attempting to reach the Azure portal will be met with a mandatory MFA requirement, regardless of their title or perceived importance. Organizations that wait until the last minute to address this will face a total catastrophe. They will deal with portal denials, broken CLI tools, and PowerShell scripts that suddenly fail, leading to halted automations and stranded deployments. This deadline is not a suggestion. It is an architectural shift being enforced directly at the control plane. You should not view conditional access policies as traditional security controls, but rather as the digital enforcement of your architectural intent. By designing these policies, you are defining exactly what is allowed to exist within your organization. You are stating that no one signs in from untrusted spots without MFA, and no one touches sensitive data from a non-compliant device. These are not just rules, they are the clarifications of your security boundaries. When you enforce these policies uniformly, you create a state of architectural inevitability where the insecure path simply ceases to exist. The system ensures the policy always wins, and the organization stays secure because you have removed the possibility of being anything else. This is the point where you stop being an administrator and finally become an architect. Zero trust, the end of implicit trust. Once you realize that identity is a continuous process, you have to start thinking seriously about zero trust. The common, comfortable assumption is that once a user is authenticated, they are officially trusted. They provided their password, they finished their MFA challenge, and now they are inside the system. We tend to treat them as trustworthy until they leave the company or until something goes wrong. We assume that at this specific moment, because they passed the initial gate, they belong here. That assumption is exactly what kills organizations. Zero trust operates on a different law. Never trust, always verify. Every single access request is treated as a potential breach until the system proves otherwise. This verification does not happen once at sign-in. It happens continuously for every action and every moment of the session. The system is perpetually asking if the identity is still valid, if the behavior is normal, and if anything has changed that should trigger a revocation. The architectural truth is that trust is not a permanent state. It is a continuous evaluation. When you sign into Entra ID, the engine looks at your device compliance, your location, and your typical behavior patterns to see if anything looks off. If the signals are green, you receive a token, but that token is not a permanent hall pass. It is merely a temporary statement about your trustworthiness that can be retracted the second your risk profile changes. Continuous Access Evaluation, or CAE, is the specific mechanism that makes this real-time security possible. CAE allows Entra ID to re-evaluate a user's status constantly rather than waiting for a token to expire at the end of the day. If a user's role changes or their device falls out of compliance, their access is revoked in seconds. If a token is stolen, the system can invalidate it immediately, stopping an attacker before they can move laterally. We see the alternative play out in the real world all the time. A user is fired on a Friday afternoon, their badge is taken, and they are walked out of the building. However, because no one immediately revoked their cloud tokens or disabled their Entra account, their Azure access remains wide open. They go home, log into the VPN, and spend the weekend exporting credentials or establishing persistence. By the time Monday morning rolls around, the entire environment has been compromised by a ghost. In a zero-trust model, that same termination triggers an automated workflow that disables the account and revokes all active tokens instantly. When that former employee tries to log in from their kitchen table, they find that they cannot authenticate or even reach the login screen. Their device is already marked as non-compliant, their sessions are dead, and the blast radius of their departure is exactly 0. This is not an aspirational goal for the future. It is the standard operating procedure for modern organizations. They use lifecycle workflows to automate account management and rely on CAE to kill sessions the moment a threat is detected. They use conditional access to ensure that every single interaction with the system is being watched and verified. The architectural truth is that zero trust is not a feature you turn on, but a total shift in your design philosophy. This model requires a combination of conditional access, privileged identity management, and constant automated monitoring. It is not a checkbox you mark off for an auditor. It is a principle that dictates how every system in your environment must be built. You are effectively deciding that being inside the network or on a corporate laptop means absolutely nothing. When you move to zero trust, you are declaring that implicit trust is dead. You are challenging every access attempt and verifying every identity, regardless of whether they are an entry-level employee or the CEO. You stop viewing access as a simple yes or no switch and start seeing it as a constant living evaluation of risk. The moment you embrace this, you realize your job is no longer about granting access, but about verifying trustworthiness forever. The AI agent explosion. Once you realize that continuous verification requires automation, your mind naturally drifts toward AI agents, and this is exactly where the architectural illusion collapses. Most organizations cling to the comfortable assumption that AI agents are merely tools under their direct control, viewing Copilot as a simple utility that responds to prompts. In this flawed model, a user asks a question, the AI provides an answer, and the human decides what to do next. The AI is seen as a passive participant that doesn't actually take actions or access infrastructure on its own, remaining just an intelligent tool that you manage like any other software. That is a fundamental misunderstanding. In reality, AI agents are not tools, they are identities. When an AI agent runs in your tenant, it functions as an autonomous entity equipped with its own service principal and specific permissions. It can authenticate to Azure, invoke APIs, and access data to make decisions that lead to real-world actions. It does all of this without waiting for a human to approve the next step or asking for permission to proceed, operating with a level of autonomy that most administrators haven't yet reconciled with their security models. The architectural truth is this: the AI agent is your new most dangerous insider threat. Consider a scenario that is playing out in organizations right now where a Copilot agent is configured with broad permissions to help users locate documentation. This agent has been granted the right to read every file in SharePoint, OneDrive, and Teams, along with every archived email in the system. When a user asks the agent to summarize their recent communications, the agent doesn't just look at the surface, it processes every single email that person has ever sent or received. It reads them, analyzes the contents, and generates a summary in seconds, effectively accessing sensitive data at the staggering speed of the cloud. The user never intended to hand over their entire life story to the agent, but because the permissions existed and the request was made, the agent fulfilled its mission. Now imagine a more calculated request where a user asks Copilot to find sensitive information across the entire organization. Since the agent has access to all documents, it can scan for patterns indicating customer records, financial statements, or intellectual property that the user isn't authorized to see. The agent finds everything because it has the permissions, and suddenly, the identity perimeter has been bypassed by the very tool meant to enhance productivity. The architectural truth is this: AI agents create action risk, not just output risk. Most leadership teams worry about output risk, which is simply the AI generating a bad, biased, or inaccurate answer that might cause a PR headache. Action risk is a different animal entirely because it involves the AI modifying or deleting components of your actual infrastructure. If an optimization agent is given permission to prune your environment, it might identify a stale resource and delete it autonomously. If that resource happened to be a backup required for legal compliance, your organization is now in breach of regulatory requirements because of a machine's decision. You cannot govern these agents the same way you govern human administrators. Humans are inherently slow, they hesitate when they aren't sure, and they generally think about the consequences of hitting the delete button. While humans certainly make mistakes, those errors are usually human scale, meaning they might delete one resource before realizing something is wrong and stopping. AI agents operate continuously at a scale that defies human intervention. They perform thousands of actions per second and interact with other agents in ways you likely didn't anticipate, cascading decisions through your infrastructure instantly. They inherit every permission of the identity they inhabit, and if that identity is overprivileged, the agent becomes a high-speed engine for architectural erosion. This is the moment you realize Entra ID is no longer just about managing people, it is about constraining autonomous identities that you currently have no framework to audit. Bounded autonomy, the new governance model. The realization that AI agents require a different governance model usually leads architects toward the concept of bounded autonomy. There is a common assumption that you can simply write a standard policy to govern these agents using conditional access or RBAC to keep them in check. You might believe that if you set enough constraints, the agent won't be able to do anything you didn't explicitly authorize, but that line of thinking is dangerously incomplete. The problem is that traditional policies only describe constraints by telling the agent what it cannot do. They fail to define intent. And when you define constraints without intent, you end up with agents that are either too restricted to be useful or agents that stay within the lines while accomplishing nothing meaningful. Bounded autonomy shifts the focus by defining the specific boundaries where an agent can play, then allowing it to operate freely within those markers. You define the intent, the constraints, and the escalation paths so the agent can do its job without stopping to ask for permission at every single fork in the road. Take an optimization agent designed to reduce cloud costs as a concrete example of this model in action. The intent is clear: find unused resources and deallocate them to save money. The boundaries are equally sharp: do not touch backups, do not modify production databases, and ignore any resource tagged as protected. Within those bounds, the agent is free to shut down a test cluster or resize an underutilized storage account without a human ever getting involved. If it encounters a situation that requires crossing a boundary, such as a backup that looks unused but is actually required for compliance, the agent escalates the issue to a human. The architectural truth is this: bounded autonomy is the only way to scale AI safely. If you reject this model, you are left with two broken choices that both lead to failure. The first choice is to over-constrain the agent until it becomes a slow human in a computer that provides no real value because it requires manual approval for every minor task. The second choice is to give the agent broad, undefined permissions and hope for the best, which inevitably leads to the agent deleting something critical during a situation you didn't anticipate. Bounded autonomy provides the middle ground necessary to capture the speed and scale of AI without the catastrophic risks of unmanaged autonomy. Microsoft Entra Agent ID is the first real-world implementation of this concept, moving it from a theoretical architectural goal to a functional reality. By giving each agent its own identity with specific permissions, you ensure it can only do what it was built to do and no more. These agents are governed by the same conditional access policies you use for users, meaning if an agent tries to access a resource from a suspicious location, the system blocks it immediately. Every action is logged and monitored, allowing you to revoke an identity the moment an agent misbehaves or appears compromised. When you disable the identity, the agent stops, and the potential for further damage vanishes instantly. The architectural truth is this: governance of AI agents is not about preventing them from acting, but about ensuring they act within defined intent. When you adopt bounded autonomy, you are essentially giving the agent a mission and a set of rules to live by. You are telling the system exactly why the agent exists, where it is allowed to go, and when it needs to stop and ask for help. This is the point where you stop trying to control AI through restriction and start architecting a framework that actually enables it to work. The observability imperative. Once you accept that bounded autonomy is the only way to scale, you realize it demands constant oversight, which is why you must start thinking about observability. Most organizations operate under the comfortable assumption that audit logs provide a complete window into their tenant because Azure writes them and Microsoft stores them for later analysis. While it is true that you can query and export these records to see what happened, relying on logs alone is a foundational mistake that leaves you architecturally blind. The distinction between logging and observability matters profoundly, yet it is a concept that almost no organization truly understands. Logging is simply a historical record of a past event, like a digital receipt showing that a specific user deleted a storage account at 3:47 p.m. last Tuesday. It allows you to look backward at the wreckage, but it offers no insight into the live state of the system or the intent behind the action. Observability is something else entirely. It is the ability to ask questions about what is happening right now and receive answers in real time. Instead of just seeing that an action occurred, you see the logic that triggered it, the specific conditions the system evaluated, and the sequence of events that followed. Observability is not a history lesson. It is live visibility into the heartbeat of your distributed decision engine. In architectural terms, flying without observability means you are operating in the dark. Consider an AI agent tasked with optimizing your costs by identifying and deallocating unused resources within its defined constraints. You might have configured its escalation paths correctly, but without observability, you can only see the results in the audit log after the VM has already been shut down. You cannot see the agent's reasoning, nor can you see which policies constrained its choices or whether it is currently drifting toward the edge of its intended bounds. Everything changes when you implement true observability because you can finally watch the agent's logic flow as it analyzes resources and evaluates constraints. If that agent attempts to touch a production database when it is only authorized for development environments, a real-time alert fires and your SOC team investigates within minutes. This allows you to stop the agent before it can do any lasting damage, effectively preventing a breach or a major design omission by preserving the environment in the moment. Without this visibility, you will likely discover the problem 3 months later during a routine audit when someone notices a database was modified by an unauthorized process. By the time you find the logs from March 15th, it is already July and the damage has been done for months. You won't know what was exfiltrated or who else has the data, which means you are now forced into a reactive incident response mode involving expensive forensic investigators and regulators. Building this capability requires 3 specific components, starting with centralized logging, where every signal from every source flows into a single system like Azure Monitor or Log Analytics. You cannot rely on logs scattered across different services in multiple formats that require manual stitching to make sense of the chaos. You need a unified, queryable source of truth that serves as the foundation for your entire security posture. The second component is the use of real-time dashboards that show the current state of your system rather than a snapshot from last week. These tools allow you to see exactly how many agents are running, how many policy evaluations are happening, and how many escalations have been triggered in the last hour. When you see the system in real time, you can spot emerging patterns and identify when something is going wrong before it becomes a catastrophe. Finally, you must establish alert thresholds and automated responses to enforce your assumptions at scale. If sign-ins spike from unusual locations or policy denials exceed a certain limit, the system should not just notify you. It should respond by revoking tokens or blocking the agent. This response must be automated and fast because observability is the foundation of incident response, and if you cannot observe a behavior, you cannot govern it. The governance loop, continuous enforcement. Now that you understand observability, you can monitor your agents and track compliance with a sense of confidence. You have defined your policies, deployed your alerts, and established an incident response plan, leading you to believe that the governance problem is finally solved. This is the exact moment where governance fails for almost every organization because they treat it as a destination rather than a process. The comfortable assumption is that a policy set once will remain enforced forever, such as an Azure policy that denies public IPs on network interfaces. You might believe that because the policy is assigned to a management group, every resource created from now on will be perfectly evaluated and secured. That assumption is a form of architectural erosion that will eventually destroy your security posture. Policies naturally drift over time as exceptions accumulate and the original assumptions about your environment begin to change. Governance without constant iteration is nothing more than a false sense of security, where you feel protected by words on a page that no longer match reality. What starts as a perfect policy quickly degrades when a developer asks for a single, temporary exception to finish a test. You grant that exception for one day, but then you forget to remove it, and soon another developer asks for a similar favor for a different project. 6 months later, your environment contains 47 exceptions to the public IP policy, rendering the original rule completely worthless. The policy still exists in your dashboard, but it has failed to enforce anything, becoming a piece of security theater that covers up the underlying chaos. The uncomfortable truth is that governance is not a static state. It is a continuous loop consisting of 5 distinct stages. You begin by defining your intent, such as deciding that public IPs should not exist, and then you move to enforcing that intent through policy deployment. However, you must also monitor compliance to find violations and remediate them by either fixing the resource or justifying a documented exception. The final and most important stage is the review and iteration phase, where you ask if the policy is still effective or if the environment has changed too much to support it. This cycle of defining, enforcing, monitoring, remediating, and reviewing must repeat indefinitely because the cloud is dynamic. If you are not iterating on your policies, you are not governing. You are simply hoping that your old assumptions still hold true. In a practical sense, this means running a query every quarter to identify which policies are being violated most frequently and investigating the root cause. You have to decide if a policy is too strict or if people are simply working around the rules for the sake of operational flexibility. Every exception must have a documented owner, a clear business reason, and a hard expiration date that you actually enforce during your quarterly reviews. Governance without iteration is just wishful thinking. And the reality of this principle is becoming clear as Microsoft's 2026 deadlines for MFA enforcement approach. These are not new requirements, as Microsoft has been recommending these changes for over 5 years, yet many organizations have failed to iterate on their internal standards. Now they are facing a hard forcing function on October 1st, where MFA becomes mandatory with no more delays or special cases allowed. Organizations that practice continuous governance are already compliant because they implemented and tested these changes years ago. For them, the upcoming deadline is just another Tuesday, and nothing changes because they have already evolved their systems to match the modern threat landscape. They didn't wait for a crisis to act. They built the requirement into their architectural DNA through constant refinement. The organizations that did not iterate are now in a state of crisis, scrambling to fix broken automation scripts that cannot handle MFA prompts. They are discovering that their most critical systems rely on legacy authentication that is about to vanish, forcing them into a cycle of desperate patching and remediation. All of this stress stems from the foundational mistake of believing that a policy was a one-time setup rather than a living part of the control plane. Landing zones as the control plane. By now you understand that true governance requires a functional control plane, but that realization comes with a price. You have to accept that a landing zone is not a template you deploy once and then walk away from. It is not a specific resource, and it is certainly not just a subscription. In architectural terms, a landing zone is a continuous governance system that never stops running. The comfortable assumption most people make is that a landing zone is just a subscription with some policies slapped onto it. You deploy a template, it creates a management group hierarchy, and then it spins up some subscriptions. That same template assigns your policies, configures the networking, and sets up your monitoring before it finally finishes. You hit the deploy button, the green checkmark appears, and you tell yourself that governance is finished. You believe workloads can now land safely because the work is done. This is a fundamental misunderstanding of the system. The architectural truth is that a landing zone is the living expression of your architectural intent written in code. It isn't something you simply deploy. It is something you continuously operate as your primary control plane. Every subscription created within that boundary automatically inherits the policies of the landing zone, and every resource created inside those subscriptions is constantly evaluated against those rules. Every identity attempting to access a resource is checked against the RBAC assignments you defined at the top level. The landing zone is not a passive folder. It is an active, breathing engine that is continuously enforcing your intent across the entire environment. When you vend a subscription through a landing zone, that container is never a blank slate. You aren't handing over a clean piece of paper that the user then has to figure out how to configure. That subscription arrives pre-configured and perfectly aligned with your core architecture from the very first second it exists. It already has the correct policies, the right RBAC structures, and the required network topology baked into its DNA. Because monitoring is already enabled and logging is already flowing, the subscription is compliant on day zero without any manual intervention. In a real-world scenario, this changes how your teams actually work. When a developer team needs a new subscription for a project, they don't open a ticket or wait for an email chain to resolve. They don't need to have a long, painful conversation with the cloud architect just to get permission to build. Instead, they go to a self-service portal and fill out a simple form with their team name, project details, and budget. Once they click submit, an automated workflow triggers behind the scenes to handle the heavy lifting. The system creates the subscription and places it into the correct management group based on the metadata provided in the form. It applies the necessary policies, wires up the network, and sets up the RBAC assignments while the developers are still grabbing a coffee. The entire process takes minutes, and the result is a subscription that is fully compliant from the moment it is born. This is subscription vending, and it represents the control plane operating with total autonomy. This is how you achieve governance at scale without relying on humans to remember the rules. The uncomfortable truth is that without subscription vending, you simply cannot scale your governance model. You can try to manually create subscriptions and hand-assign policies, but you will eventually fail because humans are inconsistent. Some environments will end up with different security postures than others, and some will have better networking than their neighbors. You will eventually wake up to a sprawl of inconsistently configured environments that were all created in the name of speed. The ultimate cost of that flexibility is that your governance becomes fragmented and meaningless. Azure verified modules have become the new standard for building these systems because they are composable, tested, and aligned with actual architectural patterns. The old enterprise-scale landing zone was a monolithic beast that tried to define everything in one giant, unmanageable template. If you wanted to customize a single setting, you had to fork the entire thing, which made merging Microsoft's updates a nightmare. That process was incredibly cumbersome and prone to human error. Azure verified modules allow you to build the specific landing zone you need by composing smaller, verified building blocks. If you need a specific management group structure or a unique network topology, there is a specific module designed for that purpose. You compose these modules together, configure your variables, and deploy a solution where every piece is versioned and maintained by Microsoft. When an update is released, you can adopt it without the pain of a manual merge, allowing you to stay current with best practices. The architectural reality is that landing zones are not actually about restricting control. They are about enabling your organization to move at scale. Without this framework, you are forced to manually audit every single subscription, which is a slow and error-prone way to live. With a landing zone, you can vend hundreds of subscriptions every month that are all secure and aligned with your organizational intent. The landing zone isn't a cage that holds teams back. It is the framework that makes massive scaling possible. It is the only way to let teams self-serve while you maintain the integrity of the system. Once you realize that landing zones require this level of scale, you begin to see the shift from managing resources to managing the decision engine itself. From resource manager to decision engine curator. As you embrace the control plane, your focus shifts away from individual components and toward the logic that governs them. You stop thinking like a resource manager and start acting as a curator of the decision engine. The comfortable assumption is that an Azure administrator's job is to manage resources. You believe your value lies in creating, modifying, and deleting virtual machines or storage accounts. You spend your days patching systems, configuring settings, and taking ownership of the physical objects inside the cloud. This is the traditional view of administration, and most people believe this is what it means to be responsible for an Azure environment. That assumption dies the moment you reach level 6. The architectural truth is that you do not manage resources. You manage a distributed decision engine. You don't actually own the resources themselves, but you do own the logic that determines if those resources are allowed to exist. You own the rules that dictate how they are configured, who is allowed to touch them, and exactly when they should be decommissioned. In this model, every policy and RBAC assignment functions as a discrete decision point within a larger system. Your conditional access rules are not just settings. They are instructions for an engine that evaluates thousands of requests every second. Your job is no longer to perform the manual labor of administration, but to define the underlying logic that the engine uses to make those choices. Consider what this looks like when you are managing 5,000 virtual machines across a global tenant. You will never personally touch most of those machines, and you will certainly never manually patch or configure them one by one. Instead, you define the high-level policies that govern the entire class of resources known as VMs. You dictate which subscriptions can host them, which sizes are cost-effective, and which networking paths are secure enough to be used. The decision engine then enforces these rules every time someone tries to create, modify, or delete a resource. Because you defined the compliance checks and the monitoring requirements beforehand, the engine acts as the primary administrator of the environment. You have moved from being the person turning the wrench to being the architect who designed the factory. This shift is fundamental to your growth. At level 1, you are just a person clicking buttons in a portal, but at level 6, you are writing the code that evaluates those button clicks. You have moved out of the execution layer and into the logic layer where the real power resides. To see this in practice, look at how a developer interacts with the system. They don't ask you for a virtual machine, and they don't wait for you to approve a ticket. They submit their request through a self-service portal, and that request goes directly to the decision engine for evaluation. The engine asks a series of deterministic questions before it allows the deployment to proceed. It checks if the identity has the right permissions and if the target subscription is currently compliant with corporate standards. It verifies the VM size, the networking configuration, and the presence of required tags while ensuring the resource is in an approved region. It even checks if the user is on a trusted device or if they have exceeded their monthly budget for new resources. Each of these questions represents a decision point that you personally defined in the control plane. If the request passes every check, the VM is created instantly. If it fails even one, the request is denied with a clear explanation. This process is transparent, consistent, and incredibly fast, which means the developer always knows exactly what is required to get their work done. The architectural truth is that this system isn't restrictive. It is actually clarifying for everyone involved. Developers appreciate knowing the rules of the road, such as which regions are off-limits or which tags are mandatory for billing. When they follow the rules, the VM appears without any friction, delays, or soul-crushing bureaucracy. But the deeper insight here is that the decision engine is entirely deterministic. It makes the exact same decision every single time, based on the rules you provided, regardless of who is making the request. There are no special exceptions for executives and no favoritism for senior engineers, because the logic applies to everyone equally. This isn't a wall of red tape, it is a masterpiece of architectural clarity. When you stop managing resources and start managing the engine, your entire perspective on the cloud changes. You stop worrying about individual instances and start thinking about entire classes of infrastructure and the logic that governs them. You are no longer an operator reacting to tickets. You are an architect designing a system of authority. The decision engine is your true control plane, and the resources are simply the physical output of that engine's choices. The control plane is what you own, what you build, and where your professional authority actually lives. Once you grasp that concept, you finally understand what Level 6 is really about. You realize the engine is deterministic, and that leads you to wonder how AI agents will eventually plug into this logic. AI agents as decision engine participants. Once you realize the decision engine is strictly deterministic, you naturally start wondering how AI agents fit into the architecture. This is usually the point where the entire mental model collapses. Most organizations lean on a comfortable but false assumption. They believe AI agents exist entirely outside their governance model. The logic is that Copilot is just a tool running on a user's device that responds to prompts without ever touching the control plane or interacting with the decision engine. You might tell yourself that you govern Azure while the AI operates in a separate vacuum, but that line of thinking is a critical architectural mistake. In reality, AI agents are not external observers. They are active participants in your decision engine. When a Copilot agent needs to reach a resource, it doesn't get a special bypass or a secret path around your security. It hits the exact same decision engine as every other identity in your tenant. The agent authenticates using its own Entra agent ID, receives a token, and then that token is scrutinized by your conditional access policies, resource level RBAC, and application authorization. To the decision engine, the agent is just another identity to be validated. While the engine treats them the same, these agents introduce a level of complexity that human users simply cannot match. The uncomfortable truth is that AI agents create a massive volume of action risk because they operate 24/7 without ever needing a break. Because they can perform thousands of actions every second and interact with other agents in unpredictable ways, they inherit every permission of the identity they represent. If that identity is overprivileged, the agent will rapidly cascade that flow across your entire infrastructure. Consider a common scenario where an AI agent is tasked with cost optimization. The intent is simple: reduce cloud spending. To do this, the agent has permission to modify VM configurations, and after analyzing the environment, it finds a VM using only 30% of its memory. It decides to resize that VM to a smaller, cheaper SKU, which is an action perfectly within its assigned permissions. The agent executes the change, but the application running on that VM immediately crashes because the smaller SKU can't handle the application's peak load. Even though the average use was low, the app regularly spiked to 90%, a detail the agent ignored because it was making decisions based on a narrow, incomplete dataset. The agent wasn't malicious or compromised, yet it still triggered a major production incident while trying to achieve its goal. This is the essence of action risk, and the only architectural answer is bounded autonomy. You can allow an agent to identify a problem and propose a solution, but you cannot allow it to implement that solution without a human in the loop. In a bounded model, the agent would create a ticket for the underutilized VM. A human would see the memory spikes during the investigation, and the optimization would be denied. By forcing the agent to operate within these specific bounds, you prevent the incident while still leveraging the AI's analytical speed. Microsoft Entra Agent ID is how you actually implement this concept of bounded autonomy. By giving each agent its own identity, you can wrap it in conditional access policies that block it the moment it reaches outside its defined scope. Every single move the agent makes is recorded and auditable, and when it hits a decision it isn't authorized to make, it follows a hard-coded escalation path to a human. AI agents are not the future of Azure administration, but bounded AI agents certainly are. You need agents that operate within clear intent boundaries and are governed as identities rather than just features. These are the only tools that will allow you to scale your infrastructure safely, because an agent without boundaries is just a disaster that executes faster than you can stop it. The governance scope: what gets governed? By now, you understand that AI agents require governance, and you've likely started building a system around bounded autonomy and observability. You have your infrastructure governed, your identities locked down, and your monitoring in place, which usually leads to a false sense of security. You feel covered until the moment a data breach actually happens. The foundational misunderstanding here is the belief that you only need to govern the things you own. You might assume that applications belong to the dev teams, data belongs to the data teams, and compliance is someone else's problem, leaving you responsible only for Azure administration. This siloed thinking is exactly what creates the opening for a breach. Governance is not a collection of independent silos. It is a holistic system where a breach occurs because multiple controls fail at the exact same time. While a single broken policy might seem like an acceptable risk in isolation, these failures eventually stack to create a catastrophic vulnerability. It usually happens in a chain of small, overlooked errors. An infrastructure failure allows a storage account to be created with public access, while an identity failure gives a user far too much permission to modify that account. Because the data team didn't classify the information and the app team used overly permissive credentials, the stage is set for a disaster. If an automation script fails silently and no one is monitoring for public storage access, you have a total governance collapse. None of these teams intended to cause a breach, but their individual failures cascaded into a single event. A user with broad permissions creates a public bucket, an attacker finds it, and they download unclassified data that no one was watching. Because the monitoring script died without an alert, the breach stays active for 3 months, and by the time you find it, the data is long gone. You have to view governance as a single system where every component must function in unison for the whole thing to work. If you create a perfect Azure policy to deny public storage accounts but fail to govern the identities that can modify those accounts, your policy is effectively useless. An overprivileged user can simply bypass the creation time block by changing the settings after the resource is deployed. The policy didn't fail because it was written poorly. It failed because the rest of the governance system was incomplete. You didn't have the RBAC controls to stop the user or the monitoring to catch the configuration drift, proving that your security is only as strong as its weakest link. If you ignore any single domain, whether it's identity, data, applications, or automation, you are leaving a hole that an attacker will eventually find. The scope of your governance must include every single one of these domains without exception. Infrastructure and identity must align with data and compliance, or the entire system loses its coherence. This isn't just a best practice you can get to later. It is the foundational requirement for operating in the cloud. Once you accept that governance is holistic, you have to start looking at the organizational structure needed to actually enforce it. The organizational structure required. By now, the reality of holistic governance should be clear. You understand that every domain, infrastructure, identity, data, and automation is woven into a single fabric. This leads to a deeply uncomfortable realization. A lone Azure administrator cannot actually manage this. The comfortable assumption is that you are the center of the universe. You own the tenant, manage the subscriptions, and write the policies. In this mental model, you are the single point of accountability for identity and monitoring alike. It feels like control, but in reality, you have simply turned yourself into a single point of failure. This is a dangerous illusion. The architectural truth is that governance at scale is a team sport, and the idea of one person owning every domain is a fantasy. No single human possesses the deep expertise or the literal hours in a day to maintain this level of control. When that person eventually leaves the organization, the entire governance structure doesn't just bend, it collapses. Mature organizations operate through distributed teams where each group owns a specific governance domain. The identity team manages the user lifecycle and conditional access, while the network team handles firewalls and private endpoints. Security and compliance focuses on policy enforcement and Sentinel, and platform engineering builds the landing zones and automation. Even the application teams have a role, governing their own data classification and access controls. Each of these teams must own their decisions. The identity team determines how MFA is enforced, and the network team structures the connectivity, just as the platform team decides how subscriptions are vended. This isn't just a division of labor, it is a distribution of architectural responsibility. However, governance requires intense coordination across these silos because without it, policies inevitably conflict. One team might create a restriction that another team's configuration immediately violates. Both teams are technically correct within their own bubble, but the resulting contradiction creates a chaotic environment where the system fails. We see this play out constantly in the real world. Security might push a policy that denies public IPs on all network interfaces, while the network team creates a policy requiring them for external connectivity. Because these mandates clash, neither is enforced reliably, leaving both teams frustrated and the environment compromised. Solving this requires more than just technical skill. It requires a structure for coordination. Teams must meet to discuss constraints and refine their policies so they work together instead of against each other. This only happens when there is clear ownership and a defined path to escalate conflicts when they arise. Most successful enterprises establish a cloud governance council. This body brings together representatives from IT, security, finance, and the business to review policies and discuss trade-offs. They ensure the governance system remains coherent and that every domain is covered by a coordinated strategy rather than a series of accidents. The architectural truth is that governance without organizational structure is just noise. You need clear roles, regular reviews, and a governing body that owns the overall system. If you lack these coordination mechanisms, you aren't managing a cloud, you are managing entropy. Here is the most uncomfortable truth for the Azure administrator. You are no longer in the execution layer. You have moved into the leadership layer. You aren't the one configuring every policy anymore. You are the one facilitating the teams that do. You aren't just governing the cloud, you are governing the governance of the cloud. The 2026 inflection point. You now see the need for organizational alignment and the distributed teams required to make it work. You understand the escalation paths and the holistic nature of the system. Then you look at the calendar, see that it's only 2025, and tell yourself there is plenty of time to iterate. This is the exact moment where most organizations fail. The comfortable assumption is that these deadlines aren't actually real. We tell ourselves that Microsoft always announces these shifts years in advance and then offers endless extensions or exemptions. You assume you can implement governance when the budget opens up or when the staff is ready, treating the deadlines as suggestions rather than hard stops. That assumption is a career-ending mistake. The architectural truth is that the 2026 deadlines represent the enforcement of architectural inevitability. On October 1st, 2026, Microsoft will mandate multi-factor authentication for all Azure portal access, including global administrators. There are no delays or special cases. By December 31st, 2026, legacy authentication will be fully deprecated across all Microsoft 365 services, and organizations that aren't ready will simply go dark. Let's look at the specific mechanics of that failure. When October arrives and MFA is enforced, your lack of preparation means you lose access to the portal entirely. Your CLI scripts using basic auth will break, your PowerShell automation will fail, and your infrastructure deployment runbooks will halt. Because you ignored a deadline announced months in advance, your entire incident response capability will sit in a state of operational dysfunction. The December deadline for legacy authentication is even more unforgiving. Your email integrations using basic SMTP will stop working, and your line of business applications will suddenly fail to connect. These aren't planned maintenance windows. They are unplanned outages that put the entire organization into a state of crisis because you refuse to modernize your protocols. These dates aren't arbitrary choices by a product team. Legacy authentication is a primary attack vector that allows bad actors to bypass MFA and move through your environment undetected. By eliminating these protocols, Microsoft is removing an entire category of risk from the ecosystem. These deadlines are how Microsoft enforces the transition to a zero-trust model. You cannot stay on legacy systems indefinitely while the rest of the cloud moves toward modern, deterministic security. This isn't Microsoft being difficult, it is the platform forcing you to accept the future of security architecture. The difference between organizations that survive this and those that collapse is how they spend their time today. Proactive teams are testing right now, discovering that half of their automation needs to be rewritten before the deadline hits. They are identifying edge cases and training their staff so that when the date arrives, nothing actually changes for them. Organizations that wait until the last minute will spend October 2nd fighting fires at 2 o'clock a.m. They will be rushing MFA deployments for thousands of users and making hasty decisions that create even deeper security vulnerabilities. They aren't governing, they are reacting to a disaster of their own making. The 2026 deadlines are a forcing function designed to make you implement governance and adopt zero trust. Organizations that use this as a catalyst for change will emerge with a more secure, modern infrastructure. Those that resist will be forced to change under extreme pressure, violating compliance requirements and suffering through avoidable outages. The question you have to answer is simple. Do you want to work for the organization that implements governance proactively, or the one that tries to fix its broken architecture in the middle of a crisis? The deadlines are real, and they are coming for your career. The career implications, levels 1 through 7. You now understand the 7 levels of Azure maturity, the illusions that define them, and the architectural truths those levels eventually reveal. Naturally, you are asking the one question that actually matters for your future. What does this mean for my career, my salary, and my professional trajectory? The comfortable assumption most people cling to is that more certifications automatically lead to higher pay and better prospects. You might believe that earning your AZ 900 leads to a promotion, followed by a raise for the AZ 104, and another jump once you secure the AZ 305. In this mental model, certifications are a simple linear equation where more badges equal more money and guaranteed advancement. That is a convenient lie. The architectural truth is that certifications are a necessary but entirely insufficient condition for real career growth. While a badge might get your resume past an automated recruiter filter or prove you studied the documentation, it only demonstrates that you understand Azure features. It does not mean you understand architecture, it does not mean you understand governance, and it certainly doesn't mean you can solve complex, high-stakes problems. Understanding is what actually drives advancement because while certifications open the door, only true architectural understanding allows you to walk through it. Let's look at what the progression actually looks like in the real world. At level 1, you are a portal clicker who knows how to manually create resources, likely holding an AZ900 and working as a junior administrator for $60,000 to $80,000. Moving to level 2 makes you a scripting apprentice where you automate tasks with PowerShell, and with an AZ104 in hand, your salary as an administrator typically climbs to between $80,000 and $110,000. Level 3 marks your transition into a template architect who defines infrastructure as code, and as an Azure Solutions Architect with an AZ305, you can expect to earn $110,000 to $150,000. By level 4, you become a governance enforcer who secures environments at scale, often holding an AZ500 and commanding a security architect salary of $130,000 to $170,000. The climb continues at level 5, where you act as an identity strategist designing zero-trust systems, and an SC300 certification helps push your identity architect earnings toward $180,000. Level 6 is the platform orchestrator who manages massive landing zones using both solutions architect and security engineer credentials, earning up to $220,000 as an enterprise cloud architect. Finally, level 7 is the agentic governor who oversees autonomous systems and AI agents, and as a chief architect with AI and identity specialties, your salary starts at $200,000 and often scales significantly higher. But here is the critical insight. You cannot skip these levels or jump from the portal to AI governance just by reading an article. You must first understand why portal clicking fails, why scripts are inherently fragile, and why templates without enforced policies create nothing but high-speed chaos. You have to learn why policies fail without identity and why network-first thinking is a dead end before you can ever hope to govern AI within a landing zone. The architectural truth is that a level 7 architect isn't the person who memorized the most Azure services, but the person who realizes those services are just tools to implement governance intent. They understand that the goal isn't to deploy more resources, but to ensure every deployment is compliant, secure, and perfectly aligned with what the organization actually intended to build. In their world, the specific resources are almost irrelevant because the decision engine is everything and the architecture is the only thing that lasts. Your career journey from level 1 to level 7 is a transition from being a resource manager to becoming a decision engine curator. It is a path of constant realization where you discover that your previous assumptions were wrong, forcing you to rethink your entire approach to the cloud. That specific discomfort and the forced rethinking it requires is what actually drives your career forward, because understanding, not a collection of digital badges, is the only real currency. The Monday morning action, what to do now. You have the levels, the illusions, the truths, and the career roadmap, but now you're sitting at your desk on Monday morning wondering what to actually do next. The research phase is over and your understanding is complete. Yet the most important question remains, how do you turn this theory into a functional system? The comfortable assumption is that you need to implement every single thing immediately, from Azure verified modules and deny policies to subscription vending and AI governance. You might feel a desperate urge to transform your entire organization before the 1st of next month, but that level of pressure usually leads to total paralysis. Trying to fix everything at once is exactly where most organizations fail because they mistake activity for progress. The architectural truth is that you must start with a cold, hard assessment of your current state. On Monday morning, do not try to launch a massive transformation or solve every architectural debt your company has accumulated over the last 5 years. Instead, focus on answering one simple question. What is the actual, measurable state of your governance right now? Your first real action on Monday morning is to audit your Azure policy usage to see how many policies are actually active and how many are stuck in audit mode. You need to run a query to find out which resources are non-compliant and identify the top categories of failure so you can export that data and face the reality of your environment. Do not assume you know what's happening in your tenants. You need to measure it. Next, you must assess your identity governance by looking at how many service principals exist and identifying which ones have been granted dangerously broad permissions. Use Entra ID governance tools to find out how many of these identities are actually documented, who owns them, and whether they have even been used in the last 90 days. Finally, evaluate your landing zone maturity by checking if new subscriptions are created through a manual process or a standardized automated workflow. You need to benchmark your environment against the Cloud Adoption Framework design areas to see if your subscriptions are following the same networking topology or if they are drifting into silos. The architectural truth is that assessment is the foundation of all meaningful change, and since you cannot improve what you haven't measured, you should spend your first week doing nothing but gathering data. Spend the first month truly understanding that data and the first quarter building a plan, because execution without a baseline is just guessing. Once the assessment is done, you have to prioritize the changes that will have the highest impact on your risk profile. If you discover that half of your 10,000 resources are violating public IP policies, that is your immediate priority, and you should implement a deny policy to close that gap. This single focus change does more to reduce your attack surface than a dozen minor tweaks that are easier to explain to your boss. Identify the one policy that eliminates the greatest risk to the business, not the one that is easiest to click or sounds best in a meeting. Your first deny policy should target the violation that would cause the most damage if exploited, so you can enforce it and remediate the existing violations before moving to the next threat. When you have that high priority policy ready, do not push it to the entire organization at once, but instead deploy it to a single test subscription to verify it works. You need to monitor it in non-production environments first to ensure it doesn't break critical systems, and only after you have confirmed its behavior should you move it into production. The architectural truth is that governance is never a big bang transformation, but rather a continuous disciplined process of iteration. You change one specific thing, measure the result, adjust your approach, and then move on to the next requirement. This requires a level of patience that most people lack, but it is the only way to build a system that actually functions under pressure. After that first policy is live, you need to establish a monthly governance review to see if violations are trending down and if your policies still align with your evolving architecture. This creates a feedback loop where you can decide whether to adjust the policy or fix the environment, turning governance into a learning cycle rather than a static set of rules. Lastly, you must communicate these wins to your leadership by showing them the direct impact on non-compliance, security incidents, and overall cloud costs. Without leadership buy-in, your governance efforts will eventually fail because someone will eventually pressure you to relax the rules in the name of speed. You aren't just clicking buttons in a console, you are changing the fundamental way your organization makes decisions, and that requires a leadership team that is fully committed to the long game. Start with the assessment, find your highest impact change, test it thoroughly, and then deploy it with confidence. This is how you build real governance. One step, one policy, and one architectural decision at a time. The uncomfortable truth. The Azure admin illusion is the persistent belief that administration is about managing resources. You spend your days clicking buttons, spinning up virtual machines, and configuring policies under the impression that you are managing the cloud. You believe you are in control. The uncomfortable truth is that you are not in control because the cloud actually controls you. In reality, Microsoft Azure functions as a distributed decision engine where you no longer manage the system, but instead you architect it. Your role is to define the logic and enforce the intent, but the cloud itself makes the final decisions. The cloud has become the administrator, leaving you to serve as its architect. When you reach level 7, you stop being an administrator and become a curator of intent. You are now the enforcer of architectural inevitability, and that is where the real power lies. I appreciate you listening to this deep dive into the 7 levels of Azure administration. If these concepts resonated with your experience, please leave a review on your favorite podcast platform or connect with me on LinkedIn. You can subscribe to the M365 FM podcast for more architectural insights into Azure, Microsoft 365, and security. Until next time, remember to think architecturally.